I am Gayatri, working as Assistant Professor in EC Department, Rotational College of Technology. Today I am going to discuss the subject Principles of Communication, Unit 1 Wireless Communication, the topic Signal Propagation. Today I am going to discuss about the signal propagation and what are the effects of multipath propagation. First, coming to the signal propagation. And like wired networks, wireless communication networks also have the sender and receivers for communicating. In connection with signal propagation, these networks exhibit considerable difference. In wireless network, the signal has no wire to determine direction of propagation, whereas in wired medium, the signals can travel along with the wire. As long as a wire is not interrupted or damaged, the signal will be transmitted. One can precisely determine the behavior of the signal traveling along this wire. For wireless transmission, the predictable behavior is only valid in the vacuum. The situation would be considered to be in following range. First one is transmission range and the second one is reflection and inference range. Transmission range, within a certain radius of sender, the transmission is possible. That is, the receiver receives the signal within the error rate low enough to be able to communicate and can also act as a sender. Then second one is reduction range. Within the second radius, the reduction of transmission is possible. That is, the transmitted power is large enough to differ from the background noise. However, the error rate is too high to establish the communication. Then interference range. Within the third even larger radius, the sender may interfere with other transmission by adding the background noise. The receiver will not be able to detect the signals, but the signal may disturb the other signal. Then coming to the path loss of radio signals. In free space, radio signal propagate as light does. That is, they follow the straight line. That is, the line of sight propagation will be followed. If such the straight line exists between the sender and receiver, it is called line of sight. If no matter exists between the sender and receiver, the signal still experiences the free space loss. The received power PR is proportional to 1 by d square, with d being the distance between the sender and receiver. Then the sender now emits the signal with a certain energy. The signal travels away from the sender at the speed of light with a spherical space. If there is no delay, the sphere continuously grows, with the sending energy equally distributed over the sphere's surface. This surface area S grows with the increasing distance d from the center according to the sphere radius S is equal to 4 pi d square. Then the radio waves can exhibit three fundamental propagation behavior depending upon their frequency. Ground wave, which is less than 2 MHz, the waves with a low frequency follow the earth surface. The skywave propagation 2 to 30 MHz, many international broadcast and amateur radio use these short waves that are reflected at the ionosphere. Line of sight, which is greater than 30 MHz, a mobile phone system, satellite system, cordless telephone, etc. use even high frequencies. Additional signal propagations. In addition to the normal line of sight propagations, the mobile phone are typically used in big cities with the skyscraper and mountains inside the building while driving through the alley, etc. Here, the several effects occurs in addition to the attenuation caused by the distance between the sender and receiver, which are frequency dependent. The extreme form of attenuation is blocking or shadowing of radio signals due to the large obstacles which are standing in middle of propagation. The higher the frequency of signal, the more it behaves like light. Even the small obstacles like simple wall, the truck, the tree may block the also signal. Another effect in the signal is reflections. Okay. If the object is large compared to the wavelength of the signal, that is huge building, the surface of the earth, the signal is reflected. The reflected signal is not as strong as the original. The objects can observe some of the signal power. This are the some of the signal propagation effects. First one, shadowing, reflections and refractions. The reflections helps transmitting the signal as no line of sight exists. This is the standard case for radio transmission in cities and mountain areas. The signal transmitted from the sender may bounce of the walls of the building several times before they reach the receiver. The more often the signal is reflected, the weaker it becomes. The following two effects, it is mostly affects our signal propagation. Which one is scattering and diffraction? The size of the obstacle is bigger, is in the order of wavelength or less, then the waves can be scattered. The incoming signal is scattered into several weaker outgoing signals. Diffraction of the waves, the radio waves will be diffracted at the edge and propagate in different directions. As shown on the right side of the figure, this effect is very similar to the scattering. The radio waves will be diffracted at the edge and propagate in different directions. The result of the scattering and diffractions are the patterns with varying signal strength depending on the location of the receiver. Scattering, it is reaching the obstacle and it is scatters. Diffractions, effects like attenuation, scattering, diffractions and refractions all happen simultaneously and are frequency and time dependent. Then multipath propagation together with the direct transmission from the sender to receiver, the propagation effect mentioned in the previous section, lead one of the most severe radio channel impairments called multipath propagation. The figure shows the transmitter where it is reaching the receiver after some obstacles, it is reaching the receivers. In multipath propagations, the delay spread occurs, shadowing occurs. Then coming to the assessment, the signal propagation effects, we know the shadow, multipath propagations, scattering, diffraction, reflections, and which of the following is not an effect caused by multipath in radio channel? First, the option is rapid changes in signal strength, random frequency modulation, power of the base station, and time depression. And obviously the option will be power of the base station. Thank you for watching.